Greetings and welcome to Fantastical Science with Miss Jenny. In this series, I transform from librarian to scientist. Just like my favorite fictional scientist, Dr. Emmett L. Brown.
All right, I'm ready. Good evening. I'm Dr. Emmett Brown. I'm standing on the parking lot at Twin Pines Mall.
And I'm going to teach you about STEAM. That stands for science, technology, engineering, art, and math. Today, we're going to focus on the T for technology. Technology has changed a lot over the years. The fact that I'm talking to you on a digital video that you accessed online is proof of that. Now, in my favorite time travel trilogy, 2015 is the year of the future.
We're descending toward Hill Valley, California at 4:29 p.m. on Wednesday, October 21st, 2015.
Here in Peoria, 2020 is a big year because it's our 100-year anniversary. See, the Peoria Women's Club founded Peoria Public Library in 1920, and a lot has changed in 100 years. So today, I actually want to focus on the technology of the past, starting with a time machine. Sadly, not this kind of time machine, but this kind of time machine, also known as a clock. You see, in ancient times, people told time with what is called a sundial. See, they used the sun and its shadows to actually be able to tell time by marking the passing of the shadows to see what hour it was. So you're going to make the same thing using a paper plate, scissors, glue, a ruler, and a piece of paper. Now what I discovered is that this is from NASA, so they like using the metric system. So if you happen to have a ruler that actually has centimeters and millimeters, please try and use it. But I have converted it to inches, so if you have a regular everyday ruler, you can do it too, all right? So what we're gonna make is we're gonna make a triangle, a right angle triangle. So the nice thing about that is that it uses two straight sides. So you can use two of your squares, straight sides from your paper. All right, so for our base, we need to have 9 millimeters or 3.5, it's about halfway in between the 3 and the 4 of inches, all right? So then you're gonna take a pencil and you're gonna measure out from the bottom 3.5 or 10 or 9 millimeters, all right? Make a little line just so you know where that is. Then we're gonna need to be able to make what is called a base so we can fold it over and glue it to our sundial. So you're gonna measure 1 centimeter or 1/4 of an inch. So an inch, normally you can do a 1/2 inch, and then 1/2 of a 1/2 is 1/4. So it's this tiny little line right there, okay? So you're gonna measure up that 1/4 of an inch and make another line. And then you're gonna take your ruler and draw straight across. And that's your base. Now for your other side, your tall side, it's gonna be 10 millimeters or 4 inches. All right, so you're gonna start from the bottom, measure out 4 inches or 10 millimeters, and that is the other side. Now to make it a true triangle, you gotta make a diagonal somewhere, and this one's gonna be connecting the two sides together, and you want it to either be 13 millimeters or 5 inches long. And you're gonna connect it using your ruler so you get a nice straight line. And you've officially made a triangle. And then all you have to do is cut it out, like so. Then you're gonna fold it along the bottom, like so. Take your fancy glue. I like glue sticks, you can use regular glue, and you're gonna glue it to your plate. Now, for it to work properly, you wanna make sure your straight side is facing at the very edge and that your diagonal side is facing in towards the paper plate. Now what you can do is you can do like I did and actually make it look like a real clock and write all the different numbers around it. And the last thing you need to do is take it outside. So now all you have to do is take your sundial outside. Place it in direct sunlight and you should see a shadow forming from the triangle you made. And when you leave it out, as time passes, the shadow will move, showing you what time it is. You've officially made your very own sundial. I like to do it because here in Arizona, we have plenty of sun to experiment with. In fact, our next experiment involves sunlight too. I'm going to show you how to make a camera obscura, or pinhole camera. Let's go back inside and show you how it's done. People use the camera app on their phone to take pictures. At a wedding or some other special event, you might see someone with a digital camera, like this one. But before there was digital, they had what is called an analog camera. Analog is a fancy word for non-digital. It means mechanical. It used buttons and gears and cranks. And this is what a film camera used to look like. And a lot of analog doesn't even use electricity, just like the camera obscura or pinhole cameras I'm going to teach you how to make today. So you need to start with either an empty, make sure it's empty, Pringles can, or an empty shoebox. You're also going to need, for these supplies, you're going to need a pencil, a ruler, a marker, wax paper, aluminum foil, a blanket, and tape, both of the Scotch and masking tape variety, and scissors. You will need to have a thumbtack push pin and a box cutter, but only with the help of an adult, all right? There's two different ways you can make one. We're gonna start with the Pringles can. So what you're gonna do, I've obviously already done it, but you're gonna measure out, using your ruler, 2 inches from the bottom. And when you do that, you're gonna take your marker and you're gonna mark where 2 inches is. Like so. And this is the part where once you've made your mark, you're going to ask an adult for assistance. Because this one, it is fairly easy once you get started, but you will need to use that box cutter. So your adult supervision is gonna pierce the Pringles can and cut all the way along. I found that I actually, once I cut it all the way out, I needed to use scissors to even it out because it was all wobbly, because you don't often cut a Pringles can, all right? But now you should have 2 parts, a short side and a long side. Then you're gonna take your wax paper and you're gonna put it around the clear lid of your Pringles can. So what you'll have to do is you'll cut out a piece and then you'll sort of figure out how to make a circle out of it and cut it out until it fits. And you can decide, it doesn't really matter if it goes on the outside or the inside, you just want to make sure it covers all the way around. And then when you're done with that, you're going to put it on the short piece, the nice little 2-inch side. Then you might need an adult's help because I had to push really hard. You take your push pin or thumbtack and you're going to go into the bottom of the thing. You're going to push down until you get a pinhole, hence the name, pinhole camera. Then you're gonna take the long part and now you gotta attach the two together. See, this is why I needed to cut it, because it was a little hard to do when it was uneven. Makes it look a little like the Tower of Pisa. All right, and then once you've attached it, you will then take aluminum foil. This is a nice full box. Aluminum foil, and you're gonna measure out 1 foot or 12 inches long of a sheet. And you're gonna take that sheet and you're gonna wrap it around. So you're gonna take your tape and you're going to attach it to the side of your Pringles can and roll it around, and probably go around about 2 times, and then tape it to the end so that it stays together like a nice thing. And then if you have any extra, you can kind of tuck it on the inside. And if it works, if you've done it correctly by not letting any of the light in, when you look inside your pinhole, you have to look. It does only work in direct sunlight or a very bright lamp that you're staring directly at. And then when you look, you will actually see an image. But interestingly enough, it's upside down because that's actually how our eyes see. Everything is upside down. Our brains then take that image and flip it so that we see the world right side up. All right, so that's how you make a Pringles pinhole camera. Now, for the empty shoebox one, it's very similar yet different. Because you're gonna take either your thumbtack or pushpin or the point of a very sharp pencil, and you're going to punch a hole into one side of the short end. So not the long end, you want the nice short end. Then on the other side, what you're gonna do, I'm gonna show you on my other shoebox just so you can see how it's done. You're going to take your ruler and measure out 2 inches, and it's a square, so it's going to be 2 inches on all 4 sides, all right? So, 1, and you want to try and make it as directly across from your other hole on the other side, so that way the light will be nice and light. And this again, when you've got your 2-inch square on all 4 sides, you're gonna use an adult supervision to use that box cutter or X-Acto knife to then cut into the cardboard. Now, what you could do is you could have an adult help you with just putting in the one side, and then once they've got a good grip, you could then come in with scissors and try the rest, but you may have to have their help with all of it because it is cutting into cardboard, all right? Now, once all the sharp objects have been put away, you will then take your wax paper once again, and this time, to be able to make the hole that goes around it, we need 3 inches by 3 inches by 3 inches by 3 inches, because again, it's a square. So you're gonna measure out 3 inches and then cut accordingly. And once you have your 3-inch square, what you're gonna do is you're gonna tape it with your tape over your 2-inch hole, like so. This is gonna be your viewfinder. And if you have a shoebox like I did, you may have to put some paper or something like that over the hole. Now this one, you actually have to use a blanket for it to work. And I learned the hard way, if you hold it up to your face like the Pringles can, you don't see anything. You have to hold it at arm's length. And then you have to actually wear the blanket all the way over yourself and the camera. So yes, it's gonna be a fun experiment. Because in the early 1800s, when they first had cameras, this is how they had to do it. You're basically creating a dark room and being able to see what happens is the light comes in the one side, and then because it's a tiny little hole, the wax paper is acting like the lens inside of a camera and only letting that certain image in, and that's what you see. But in this one, because of the way the light's gonna wanna shine everywhere, you have to create a dark room. The last blast from the past I wanna teach you guys about today is telephones. Like the camera anymore, people today use their cellular phones, smartphones. You might even see someone using a flip phone. And if you go to a business, you might see someone answering what is called a landline phone. It is called that because there are telephone cords or lines that connect the receiver to the speaker that then goes to the wall, that then goes to lines in the ground. And anytime you're on a road trip and you see those telephone poles, that's what they're doing. They're called landlines because that is how you make a telephone call, or at least how you used to. So today we're gonna do an old school but classic way of making your own telephone. So obviously you need either 2 paper cups or 2 plastic cups. If you have an adult supervision and are feeling adventurous, you can even use 2 tin cans. But for today's experiment, we're gonna be nice and easy with plastic and paper. So what you're gonna do is you're gonna take a thumbtack or push pin and you're going to make an impression into this. Now you might have to make the hole a little bit bigger because you're also gonna need string. You need at least 10 feet, if not 20 feet of string. And you're going to thread it through your hole, which is sometimes easier said than done because you don't want the hole too big that the string falls through, but you want it small enough that it stays tight. Another way to make sure the string doesn't fall through, take a paper clip and you're gonna tie your string at the end of it once it's inside the cup. If you do it when it's outside, it makes it a little bit harder. But this way it ensures that the string stays in place. Now for this experiment, you obviously are gonna need to have a friend, family member, someone who's willing to take your call, so to speak. And you also have to make sure that it's tight. If it's a little bit loose, it's not gonna work. Just like we learned in our science of sound, the way this experiment works is it's the vibrations in the actual line itself. So when you talk into the side, someone on the other end is going to hear it. And they're hearing it because the vibrations of your voice are going all the way along, but only if it's taut. All right? So you're gonna have to be able to find a place somewhere normally outside that you can stretch out 20 feet and try it. And then you can experiment with the shortness or the longness of it. And then you have yourself your very own paper or plastic cup telephone. Fun fact, Alexander Graham Bell, the inventor of the telephone, used to think that when we say, you know how we say hello, he wanted everyone to say ahoy when they answered the phone. Just doesn't have the same ring to it. Thank you guys so much for joining me. In Fantastical Science, we've learned about the T for technology and gone back into the past, and we didn't even need 1.21 gigawatts.
1.21 gigawatts!
Watching these videos, you can actually earn points for the summer reading program. So if you go to read20az.org and enter the secret code out of time with a 0 instead of an O, you can earn points just for watching this video. So thank you again for watching T for Technology. Next time we'll be looking at E for Engineering in the future.